Okay, a lot of information is available from a balanced equation. So if we have the equation that 2Fe plus 3S make 1 iron sulfide, we can read that as atoms. 2 atoms of iron and 3 atoms of sulfur make 1 molecule. We can also read that as moles. 2 moles of iron and 2 moles of sulfur make 1 mole of iron. And this is supposed to be iron sulfide. Sorry. Also, mass is conserved in a reaction. Okay, so we can use the recipe method to determine mole-mole factors, or we can use the coefficients from a balanced equation, and we're going to do this both ways. Mole-mole factors is just a fancy way of saying that we're going to convert one substance into another substance. Okay, so let's first check the recipe method out. Let's start with this problem right here. How many moles of iron oxide can be made from 6 moles of oxygen? All right, well, as our equation is written, we have 4 moles of iron and 3 moles of oxygen make 2 moles of iron oxide. We want 6 moles. So if we just double the number of oxygens, we'll get 6 moles of oxygen. And just like if you were making cookies, if you double the reactants, you'll make twice as many cookies. So we'll also have to double the iron oxide. So we're going to make 4 moles of the iron oxide. So if we double the oxygen, we'll get 6 moles, and that's the number in our problem. So we also double the amount we make 2 times 2 is 4 for 4 moles of the iron oxide. Just for completeness, let's double the iron. We're going to take 8 moles of iron. Okay. So we can also, let's do another example. You can shut the video off and see how you do on this one. How many moles of iron are needed to react 12 moles of oxygen? So I'd like this to be 12 moles of oxygen. If I multiply 3 by 4, 3 times 4 will give me 12. But if I do that, I need to do that to all of them. 4 times 4 will give me 16 irons, 16 moles of iron, and 2 times 4 will give me 8 moles of iron oxide. Let's look at another example. How many moles of iron are needed to react with 2.75 moles of sulfur for this reaction? Well, we need 2.75 moles of sulfur. That's not going to be even like the other ones were. The other ones I could double or quadruple the recipe, the formula, but this one's not going to be so easy. What we can do is we'll need to figure out what we need to multiply 3 by to get 2.75. So if we take, 2.75. 2.75 divided by 3 will give us 0.916. I take 3 and multiply it by 0.916, I'll get my target number. So now I just needed to multiply everything by 0.916 times 0.916. And the question asks how many moles of iron, so that's the one we're interested in, and it ends up being 1.83 moles of iron. And we're going to make 0.916 moles of our iron sulfide. Okay, so let you give yourself a shot at these. How many moles of oxygen are required to react with 2 moles of hydrogen? How many moles of hydrogen are needed to react with 5 moles of oxygen? How many moles of water form when 2.5 moles of oxygen react? So these are 3 different problems. You can turn off the tape and then I'll show you the answers. Okay, let's start with the first one. How many moles of oxygen are required to react with 2 moles of hydrogen? Well, we can look at this as written. This is 2 moles of hydrogen. We're reacting 1 mole. 1 mole of oxygen reacts with 2 moles of hydrogen. How many moles of hydrogen are needed to react with 5 moles of oxygen? Well, if we multiply this by 5, we'll have 5 moles of oxygen. If we do that, we need to also multiply the hydrogen by 5. We get 10 moles of hydrogen. The last one is how many moles of O2 of water form when 2.5 moles of oxygen react. I'll probably have to rewrite the problem for this. 2 hydrogens plus 1 oxygen makes 2 waters. And we're wanting to react 2.5 moles of O2. So we'll have to multiply this by 2.5, multiply this by 2.5, multiply this by 2.5. So 2.5 times 2 will give us 5 moles. So that's the recipe method. There is also another method, and I want to take the time to go back and show you how to work the other method. The other method uses the coefficients from a balanced equation and conversion factors. So for this first one, we're given the 6 moles of O2. We'd like to convert that into moles, an unknown number of moles of iron oxide. Okay? So we need a way to relate moles of oxygen to moles of a completely different compound. We can use our balanced equation to do that. We know that, and let me get another color. From this balanced equation, 3 moles of oxygen makes 2 moles of the iron oxide. So now we have a plan. We're going from 6 moles of oxygen to an unknown number of moles of iron oxide, and we have an equality that relates the two, moles of oxygen and moles of iron oxide. Remember, these numbers that are in front came from right here and right here from our balanced equation. So now we're ready to set up our problem. I'm going to set it up here. Hopefully I'll have room. 6 moles of oxygen. Then we'll want to write our conversion statement. We've got moles, 3 moles of oxygen is equal to 2 moles of iron oxide. This is what we want to use to write our conversion. We want to put the moles of oxygen in the bottom so that they will cancel, and our 2 moles of iron oxide in the top so that that will be in our final answer. Whoops. Our moles of oxygen cancel. What we've got here is 6 times 2 is 12 divided by 3. That gives us 4 moles of. And this is the same answer that we got here. We just got there a different way. So let's try it on the next one. We're starting with 12 moles of O2. We're converting that into moles of iron. We need to know how moles of O2 relate to moles of iron. We can use our balanced equation. We've got 3 oxygens combined with 4 irons. So I'm going to write that 3 moles of oxygen equals 4 moles of iron. You're going to have to take that equals with a grain of salt. That means that 3 moles of O2 is going to combine with 4 moles of iron. Okay, so now we're ready to write our problem out. We're going to start with our 12 moles of O2. That number came from the problem up here at the very beginning. Okay, that's what we started with. And we're going to convert or change it into iron. And we're going to do it using this equality. We want moles of oxygen to be on the bottom and moles of iron to be on the top. And we've got 12 times 4 divided by 3. That will give us 16. And moles of oxygen cancel, so this is moles of iron. Okay, let's look at one more. Here we've got moles of sulfur, 0.75 moles of sulfur, and we'd like to know how much iron it's going to combine with. Okay, we can look up here at our balanced equation and see that 3 moles of sulfur will combine with 2 moles of iron. So now we're ready to write our problem. We'll write 2.75 moles of sulfur. Then we're going to use our equality to write a conversion statement. Moles of sulfur is going to go in the bottom. And the 2 moles of iron will go in the top. And we'll get the same answer as we got before. We'll still get the 1.8. This method is a little bit better because you're able to put it in line with the other conversions that you're doing, and it can be a little less confusing. But if you like the recipe method, it also works.